part that in the earlier in the earlier part we discussed about biofuels. Biofuels, we have to shift to biofuels because we are having less amount of crude oil reserves which are there, and carbon dioxide is also increasing, and thus will be increasing the increasing the global warming, as you see from this graph. So what are the alternates we are having? The alternates we are having is the hydrogen fuel cell. So in the hydrogen fuel cell, we have to know that what is happening over here. In the hydrogen fuel cell, see, in the earlier videos, if you see, we have already discussed that you have to know this trick, right? In any electrochemical cells, anode, cathode is there. In any
Yeah.
electrochemical cell, we have to know that anode is the electrode where electrons are released. You can write down, right? Electron are released. Is it clear to you? Fine. Cathode is the electrode where electron is is actually gained. Understood? Or absorbed.
Yeah.
Clear? This concept is applicable for VC cell. This concept is applicable for eukaryotic cell. This concept is applicable for the secondary cell. This concept applicable for the hydrogen fuel cell also. Universal. This trick, please note down this. Anode is the electrode where the electrons are released. Cathode is the electrode where electron is absorbed. Right? Clear?
Yeah.
Now, in the hydrogen fuel cell, what we are doing? That's a very important portion we have to learn.
Yeah.
So, we are discussing about the alternatives method to generate electricity or generate energy, because we are heavily dependent upon fossil fuels, and fossil fuels are very limited, right? Very limited. So this is a very important portion we have to learn, that whenever we are seeing the alternative method is hydrogen fuel cell stands alone with direct methanol fuel cell. The two case studies you are there in IBDP. Now if we see, when we are talking about the hydrogen fuel cell, in the hydrogen fuel cell, this is very important. This is R 1.3.5, this particular part. Now, if you see that the hydrogen fuel cell is called as a secondary cell, right? Is a secondary cell. So if you see that in this cell, this is an electrochemical cell. Same applications. Anode will be electron will be released. Cathode the electron will be absorbed. Now,
Yeah.
what we do, we are taking graphite electrodes. We're taking graphite electrodes, and in between the graphite electron, we are using a proton exchange membrane. What is a proton exchange membrane? That you have to see. Proton exchange membrane is a membrane which will be allowing only H plus ions to move, right? H plus
Yeah.
ions to move. They won't allow any other ions to move around. Number one. Number two, electrons will not be able to move around from this. So proton exchange membrane is what? Exchanges proton only, selectively. They won't allow electrons or any other ions to pass through it. Done.
Yeah.
Now, what happens? We are taking hydrogen in hydrogen cylinders, and this hydrogen cylinder we are pumping in what? We are pumping in the hydrogen gas. We are pumping in hydrogen gas. Now, at the cathode, what we are doing? At the cathode, we are pumping in oxygen from the air, right? Free oxygen is free from the air. But hydrogen we are pumping in from the hydrogen cylinders. Now, here is very important thing, that we have to know that what happens in this anode, oxygen is released. So our anode always oxidation is happening, oxidation. So the reaction
Yeah.
is how? The reaction will be H2 plus 2H plus gives you 2E. This is a reaction which happens, H2 plus 2H plus 2E. In this part, we have to know that this two electrons which is released will be going up the wire, right? And we put a electrical motor over here, and it drives the electrical motor, right? Now,
Yeah.
the hydrogen ions which is released will be going via the proton exchange membrane to the cathode. Now, the electrons will be going via the wire, and it will be sitting just 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 on the cathode, waited to be absorbed. In cathode, what we do? In cathode, we are pumping in oxygen gas. This oxygen gas will be reacting with what? Reacting with the H plus coming from the anode, and 4 electrons will be absorbed at the cathode, and we are getting H2O. This is the reaction which is happening at the cathode. Done this part? Now we know
Yeah.
that ultimately we have to balance the electrons. Anode has got 2 electrons. Cathode has got 4. We have to multiply this by 2, and what do you get? You get 2H2 plus 4H plus 4E. Now we add these two reactions. So 4H plus gets cancelled, 4E gets cancelled. And what is
Yeah.
the total reaction? 2H2 plus O2 gives you 2H2. This is a very important reaction we have found out, right? Now ultimately, so in this reaction, the benefit is what? The benefit is the product. See, harmless product. In the cars, in the buses, in the aircrafts, carbon dioxide is emitted, right? Greenhouse gas.
Yeah.
Now, this is the advantage of this, and this gives you a huge amount of energy. Now, moving to the next part, we have to know that when we talk about the part of the sourcing of the hydrogen, right? So we are trying to take this hydrogen fuel cell. Why we are trying to take this hydrogen fuel cell? To reduce our dependence on fossil fuels, right? Isn't it? That is our
Yeah.
main objective, and make Earth, Mother Earth, a safer place, right? Means the carbon dioxide gas release, which is there, will be increasing the greenhouse gases. Now we have to debate over it. Now, the sourcing of hydrogen which you do in the hydrogen fuel cell, this is coming from mainly two sources. First is electrolysis of water. In electrolysis of water, what do we do? In electrolysis of water, we take water and we electrolyze it, isn't it? We electrolyze it to what? Hydrogen and oxygen, right? Now, this electrolysis of water will be taking what? This electrolysis of water will be taking electricity. Will we? Will be
Yeah.
taking electricity. And electricity till now, 90% of the electricity is used, will be coming from burning of coal, right? We burn coal to generate electricity. Is it clear? You get my
Yeah.
point, right? So this is a very important point we have to master. Now, moving to this part, next thing is that we can also get the hydrogen. So this again, so by increase of water, what we do? We are sourcing this electricity current from burning coal, isn't it? So it
Yeah.
it, it 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 is not making any sense, right? It is not making any sense. But
Yeah.
yes, we can also generate electricity by solar energy, so that will be better, right? Till now
Yeah.
we are using the electricity of water from electricity generated from coal. The second way by which we can get the hydrogen is what? The steam reforming. Now in the steam reforming, what we get? We take natural gas, we pass through steam, it gives you carbon monoxide plus hydrogen. So this source of hydrogen is there. Next, the carbon monoxide gas which is coming out will be reacting with further steam to give you carbon dioxide plus H2. Is it clear? So we are getting the hydrogen gas over here by steam reforming. Now, in this reaction, what you're seeing, the carbon dioxide is released. So our main purpose was to reduce carbon dioxide gases coming out in cars and buses. But when we
Yeah.
source hydrogen gas, we are still using this steam reforming, which is there, which is releasing carbon dioxide also, right? So this is a very important portion we have to keep in mind. Now, the second kind of cell is what? The second kind of cell, which is greener, you can tell, right, greener cell, right,
Yeah.
or green chemistry cell, is called a direct methanol fuel cell. In the direct methanol fuel cell, we are having methanol. Now, in methanol, we can make methanol from what? We can make methanol from fermentation, right? We can make methanol from all the fermentation process. So it's a renewable source of energy, right? Now you have to memorize this. In the direct methanol fuel cell, what's happening over here? And also, I'm telling you that the direct methanol fuel cells comes in very portable sizes, right? You can carry on your hand, right? Isn't it? To
Yeah.
to to, to power laptops, to power video cameras, right? What happens over here? In the direct methanol fuel cell, methanol is taken at the anode. And anode, what happens? The electron is released with reaction with H2O. What happens? It gives you carbon dioxide plus 6H plus 6C. Got it? The same thing is open, that we have taken a proton exchange membrane. So the H plus ions will be going via the proton exchange membrane to the cathode, and the 6 electron will be going via the wire and driving a motor, right? Or electric motor, right? And in the cathode, what we're doing in the cathode, we are pumping in oxygen, right?
Yeah.
So
Okay.
so ultimately the reaction is what? The ultimate reaction is, you have to take this, 3.5 O2, like this. 3.5 O2 plus 6H plus 6C gives you 3H2. So see, over here, what's the total reaction we are getting? If we add these two reactions, 6H plus gets cancelled, this gets cancelled, we are getting what? Methanol plus 3H3 by 2O2 gives you CO2 plus H2. So this is the overall reaction we are getting, right? Yes. In this particular reaction, we have to see that what are the disadvantages. The disadvantages are properly mentioned over here. See, wonderful. The main disadvantage is that methanol is extremely toxic, right? Can kill human beings, right? Can kill human beings. Methanol is extremely toxic. Second particular negative point is what? It releases carbon dioxide. Can you see this? This
Yeah.
reaction releases carbon dioxide. So that's a greenhouse gas, right? Now, the third important point is that this reaction, we do what? We take a catalyst in the anode. We have to take a catalyst in the anode to make this reaction faster. This reaction, right? Usually
Yeah.
does not happen on its own, right? Now that contains what? Precious ruthenium and palladium, right? Do you get my point, right? We have to use a
Yeah.
precious rare metal, ruthenium and palladium for the reaction. So these are the disadvantages we are getting. Now, again the same thing. The advantages will be outweighing the disadvantages. What are the advantages? The advantages will be there, that this particular the direct methanol fuel cell, right? This is also very very important because of the fact that it has got a high energy density, right? See, we have discussed what is specific energy. We discussed this specific energy.
Yeah.
Specific energy is the energy in per kg of the fuel. Specific energy. What do you mean by energy density? And what do you mean by energy density? Energy density is equal to the energy which is given out per volume of the fuel, right? Is it clear?
Yeah.
The direct methanol fuel cell, you'll be seeing that methanol has got a very high energy density. What is energy per density? We have to know that it is the energy per unit volume, right? So if you compare this direct methanol fuel cell, it has got a very high energy density. Right, this part? This is clear to you? Fine.
Yeah.
Now, this is all about what? This was all about the portion of the of the direct methanol fuel cell and the hydrogen fuel cell. See, it's a very good example given you. Just remember one thing: specific energy is the energy per mass of the fuel. Energy
Yeah.
density is the energy per volume of that fuel. Whenever you have to compare, this is very important things we have to master over here for transportation and storage, energy density, right? This. Do you get my point? Under this part, suppose I'm taking hydrogen, right? So hydrogen, if you take suppose I'm taking 46 grams of suppose hydrogen. I'm taking 46 grams of ethanol,
Yeah.
C2H5OH, right? So can you find out what is the specific, what is energy density? Energy density is equal to the energy divided by the volume of the gas in decimeter cube, or volume of the fuel in decimeter cube. So how many number of moles are there in 46 grams of hydrogen? 46 divided by 2, that is 46 moles. How many
Yeah.
moles are there in the 46 grams? Same amount of the faint amount of this per methanol. 46 divided by 46, that is 1 mole, right? Fine.
Yeah.
Now we have to convert this. We have to convert this into the volume. So how much is the volume? So if you take hydrogen, it is 46 moles. And how much is the particular volume? You are using this formula, right? That number of moles into 22.7 decimeter cube will be equal to the volume of the gas in decimeter cube, right?
Yeah.
So 46 into 27.7 decimeter cube. So how much are you getting over here? Please take out your calculator. 46 into 22.7 decimeter cube. And ethanol, we are getting what? Ethanol. For 46 grams, we are getting 1 mole for 46 grams, right? So,
Yeah.
so the ethanol is what? Number of moles is 1, and 27.5, that is 23.7 decimeter cube. How much particular volume you are getting for 46 grams of H2? Tell me.
You're getting 1044.
No, no, here. 46 divided by into 46 into 27.7. Tell me.
Yeah, 46 times 22.7 is 1044 cent.
1044 dm cube, right? Isn't it?
Yeah.
So can you understand this thing? In order to store 46 grams of hydrogen, how much volume of the container you need? How much? 1044 decimeter cube.
Yeah.
To store 46 grams of ethanol, how much volume you know? How much you have to take that particular container? 22.7. Did you get my point?
Yeah.
So if you see that hydrogen and ethanol is releasing the same amount of the energy, suppose. So hydrogen specific density, the energy density will be how much? ED? 100 divided by 1044. Whereas for ethanol, right, the energy density for the same energy will be how much? 100 divided by 22.7. Did you get my point?
Yeah.
That the main problem with hydrogen is that storage and transportation. Isn't it clear? To
Yeah.
get my point? So this energy density is very important for when we are trying to compare the transportation, right? In the storage. To get my point? This part is very important, right? That if anything has to be stored, right? That thing you have to understand, right? Just specific, and the energy density comes to the picture. Done this part? Okay.
Yeah.
This is a very important portion, right? This is a very important portion. I'll be really requesting you to. I'm just sending in this calculations to you. Just 1 minute. Give me a minute. 1 minute. Did you get my point? So energy density is the energy released per unit volume, and specific energy is the energy released per unit mass. So specific energy is very important when you are finding out that how much energy it gives you. See, hydrogen is a very good fuel. See, it gives a huge amount of energy, right? Isn't
Yeah.
it? Than petrol. But if you want to know about the transportation and storage, this completely is a disadvantage, huge disadvantage, right? Isn't clear this part?
Yeah.
So this is there in R 3.1.3.3. So just hopefully you subscribe to that, right? Thank you so much.